Right, welcome back. So this is our last session. I am Duminder. So we have 3 presentations again for this session. And each presenter will have 20 minutes followed by a discussion time of 5 minutes and then 5 minutes for the question and answers. So let me invite our first presenter for this session. The session is titled Transition Risks. Yeah. Then let's invite Fraser Holding from the University of Queensland until Lillian is ready. So Fraser is presenting setting a science-based carbon target. Who's doing it and do markets care? So it's over to Fraser.
Okay, sorry, I didn't have my slides ready. Give me 1 second.
Okay, it's okay.
Just find them. Hang on. Okay. All right, just going to share my screen now.
She's going to present next. Otherwise, she will start. Okay, you can now go to slideshow.
Can you guys see that?
Yes, maximize it. Yep.
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 That's,
Uh,
you got the presenter view?
yeah, it's a presenter. Can you share the?
Yeah.
Yeah, perfect.
Cool. Okay. All right, so kia ora everyone, I'm Fraser Holding. I just want to start off by saying a big thank you to the CEF Group and the University of Otago for accepting my paper into this conference. Just a bit of a background, as someone mentioned, I'm a undergraduate student at the University of Queensland. So this paper was my honours thesis, and currently with my supervisors, Safira and Suman, we're trying to turn this into a peer-reviewed article. So any feedback is very welcomed, as you know, I'm still learning along the way as well. So the paper's titled Setting a Science-Based Target, Who's Doing It and Do Markets Care? So I thought I'd just start out with what is a science-based target, as there's many definitions in the literature and out there in the corporate space at the moment. So there's several definitions for science-based targets. However, our paper defines a science-based target as a target that's approved by the Science-Based Targets Initiative, or the SBTI. So the SBTI manual defines a greenhouse gas emissions reduction target as science-based if it's in line with what the latest climate science says is necessary to meet the goals of the Paris Agreement. So as you can see over there on the right, I've got a little flow diagram about how the process works. So an organization commits to set a science-based target. They then have 2 years to set that target. They submit their methodology and their figures off to the SBTI. They then review the target and categorize it into 3 categories: below 2 degrees, well below 2 degrees, and below 1.5 degrees. If the methodology isn't approved, the target is denied and sent back to the organization. They still have that 2-year window to send through a new target. So in this paper, that's what defines a science-based target. So the foundation of the paper, there's really 1 or 2 key underpinnings, but the main one is the one on screen at the moment. So the rise of the science-based targets. So the Science-Based Targets Initiative arose from 2 things. At first, a corporate need to legitimize decarbonisation targets, and the second, a community and investor need to hold organizations accountable for these targets. Now, these science-based targets have becoming increasingly popular in the last 5 years. So as you can see over there on the graph on the right, when the initiative started in 2015, there was only 12 firms with science-based targets, and we've seen exponential growth year on year to the most recent figure being 2,000 firms who have committed to or have set a science-based target. Now there's a growing prominence of these in the world's largest organizations as well. So as you can see over here on the left, 20%, almost 20%, or 156 out of the 900 firms in the S&P 900 have or are committed to set a science-based target. So we're seeing this number grow and grow and grow, and it's very prominent among larger firms as well now. And further that, the number and range of organizations is quickly growing. So they're expanding, they've received funding from the Bezos Fund and other funds to expand the reach of this. So they've looked at for portfolio managers having their portfolios assessed as committed to science-based targets. And they're also doing a net zero piece as well now. So the role of science-based targets as a corporate decarbonisation tool has grown significantly over the last couple of years, and it's a tool that can't be ignored, and it really is calling out for further investigation into the underpinnings and workings of these targets. So due to the recency of science-based targets, there's really quite limited literature on science-based targets, and the findings so far have been have sort of conflicted. Especially when it comes to the effectiveness of the targets. So there's a handful of papers. The three I've sort of focused on is the three you'll find on screen there. The first one by Freiberg, Growell, and Serafine. It's one of the seminal papers, and it looks at firms who had previously set emissions targets and then translated to science-based targets. So they find that firms who have previously set a target are more likely to set an SBT, or a science-based target. Manager perception of climate risk is a determinant of setting a science-based target. Setting a science-based target does result in an increase in target difficulty. And in the 2 years following the setting of a target, firms' emissions decrease and carbon positive investment increases. Further, the Ramadori and Zeni paper, they find that manager perception on the impact and likelihood of climate regulation and carbon regulation, results in an increased likelihood of a firm setting an SBT. And then the Gasekum, Norman, Garvey, and Betts Davies paper finds that after the first 2 years, 50% of firms have actually missed their emissions targets. So what do the findings imply, and what are the implications for this study? So the first is that the determinants identified already by the literature have all centered on manager perception of climate risk. So this doesn't identify the types of firms that are setting targets. And many market participants, they're not going to be evaluating management responses to CDP data, because if you've dealt with CDP data, you'd understand how large and wide the data is, and the breadth of responses that you get in there. The second key finding is there are mixed results around if SBTs are met by organizations, or if they're an effective tool at increasing organization effort to meet their commitments. So the mixed results, it's a bit early on in the piece to see if these targets have been successful, due to the reason that many investment decisions are lagged, and the road to decarbonisation isn't linear. It's obviously follows quite an unlinear pattern. So it's kind of too early on in the piece to assess if these targets will be successful. Further to this, there's also no literature on the market reaction to the firm implementation of a science-based target. So the two research questions that built from the rise in popularity in the literature that we look to address are the following. So what are the capital market determinants of firm implementation of a science-based target? So as I said earlier, many market participants don't have access to the CDP data, but still want to assess which firms are implementing science-based targets. So the importance of this is, once we identify the certain types of firms that are more likely to implement targets and what's effective at implementing a target, we can identify a benchmark. We can identify which firms are the laggards, which firms are leading the way, and then investors can use this information to put pressure on firms that are lagging behind in their industry, or to comparative firms. The second is, what's the market reaction to firm implementation of a science-based target? So as I said earlier, it's too early on to evaluate if these targets are successful. So we've taken the view, instead of evaluating how if the targets are successful from the perspective of actual emissions reduction, why don't we evaluate it from the perspective of looking at how do the markets believe, do the markets believe that it's going to be effective? So essentially looking at, do the markets think that these firms are signaling their quality to the market in an attempt to reduce their carbon risk and future reduce their risk? Or do they believe they're greenwashing and trying to legitimize their greenwashing by setting these targets and actually have no intention of following up? So those two research questions, we've essentially split the paper into two sections. The first looks at the determinants, and the following hypotheses have sort of been developed around the determinant section. So there's limited literature on environmental target setting. So we've sort of broadened the scope, and we've looked at the determinants of effective CSR, ESG, sustainability management, and then we've applied this to the setting of science-based targets as well. So we've come up with 6 hypotheses here that look at possible capital markets determinants. So the first is the industry peer effect. It looks at the number of firms in the industry has a positive relationship with the implementation of a science-based target. The second and third look at industry carbon intensity. So it looks at the first one's H1B says that firms with higher carbon intensive industry will have an increased likelihood of setting a science-based target. And the theory behind that is that a firm that is more exposed to carbon risk will have a higher likelihood of setting the target in order to reduce their exposure to carbon risk. The second hypothesis, the alternative hypothesis, looks at firms with a lower carbon intensive industry being more likely to set a science-based target. And the theory behind this is it requires less investment, and some firms will be very close to in line with the Paris Agreement already, so that they're more likely to set a target there. H1D looks at internal governance mechanisms. So board independence, board diversity, board size, and the presence of an environmental committee is positively related to the likelihood of firms setting a science-based target. H1E then looks at external governance, so ownership, concentration, and power, and analyst coverage, and we've hypothesized that a positive relationship. So the theory for those two is obviously the internal governance mechanisms and external governance mechanisms will be driving firms. If they're effective, they'll be driving firms to essentially implement science-based targets based on resource dependency theory, based on stakeholder theory, etc. The final one, based on a lot of the findings by Clarkson, is firm size and financial performance. So larger firms, due to resource dependency theory, and financially strong performing firms will be more likely to implement a science-based target as well. So we've sort of cast a wide net here, as probably should be done in a lot of early papers, to sort of identify any relationships for further interest in the literature as well as give firms, market participants an idea of the sort of firms that are setting science-based targets. The second is the market reaction. So for market reaction, instead of using share price, we've used cost of equity. So the reason that we've done this is based on the papers by Kim, Bowie, and some other papers on carbon risk as well. So these papers by Kim have found that Kim et al. And Bowie et al. Have found that carbon risk and carbon intensity is directly tied to cost of equity. And this is due to the increased volatility of future cash flows due to the possible implementation of carbon regulation. So if carbon intensity is directly tied to cost of equity, then the setting of a science-based target should essentially signal to the market that firms are going to reduce their carbon emissions, reduce their exposure to carbon risk, reduce their the volatility of their future cash flows, and subsequently reduce their cost of equity. So the H2A says that firms that set a science-based target are assigned a lower cost of equity than their industry peers who have not set a target. And the effect of this scales with average emissions intensity, industry emissions, sorry. So essentially looking at the magnitude effect identified by the industry emissions says that firms with higher emissions have a higher cost of equity. They're going to face a larger reduction and subsequently should face a larger reduction in cost of equity. So that's H2A. H2B looks at the flip side of this. It says, well, what if markets believe that firms aren't going to meet these targets? What if they believe that the firms are doing essentially greenwashing and they're looking to validate their targets, but with no intention of meeting them? So in this hypothesis, we say that firms that set a science-based targets are assigned an actual higher cost of equity than their industry peers, and it scales again with average industry emissions. And the reason for this is that the firms with higher average industry emissions will have to make a higher capital investment. So these are the two. This is the market reaction hypothesis. So moving on to the empirical design and results of the paper. So again, it's split into two sections: determinants and cost of equity. However, it sort of has a very similar sample and data. So the sample is S&P 900 firms from the 2015 to 2021, and that's made up of the S&P 500 large cap and the S&P 400 medium cap. The US was chosen as a leading global decarbonisation efforts in a corporate sense, extremely efficient markets, wealth of analyst forecast data, which is needed for the cost of equity calculations as well. So the sample statistics down there show there's 900 firms in the sample. Firm year observations are 7-year period, 6,300 firm year observation, and firms who have set a science-based target is 156, or as we said earlier, 17.33%. The data is sourced from all the regular places that you see in ESG papers, so nothing out of the ordinary there. The only thing to probably highlight is that the emissions are from Refinitiv Icon, which looks at CDP data as well. So moving on to the methodology. So for the determinant section, a time series logic regression model is used to evaluate the determinants of firm likelihood to implement a science-based target. So the dependent variable in this case is a binary variable that takes the value of 1 in the years where a firm has implemented a science-based target. As you can see there, it's quite a large regression, obviously room for multicollinearity issues. So the regression is run as a whole, and then it's split into the different hypotheses as well to account for that multicollinearity. So as you can see over here on the right, we have a number of variables that evaluate the different hypotheses. So the first two look at the number of firms in the industry, number of firms in the industry in the year prior. We've got industry emissions, financial performance, internal governments, external governments, and control variables there. So the fixed effects, we use year and industry fixed effects, and we cluster for standard errors at the firm and year level. So the results. So being a logic regression model, the coefficients are displayed as the odds ratios. And as you can see across here, we've got some significant key findings. So the first key finding is that industry peer implementation of an SBT is significant and possible. The way to interpret the coefficient is if the number of firms in the industry increases 1 standard deviation away from the mean, then a firm is 12.4% more likely to implement a science-based target. If that happens in the year prior, then it's 26.8% more likely. The second is that strong internal governance mechanisms are also a determinant of firm implementation of a science-based target. So we look here and we find that board size, board diversity, and ESG committee specifically are strong determinants of firm implementation of a science-based target. So essentially saying effective internal governance mechanisms can result in a high likelihood of setting a target. External governments, we find a very similar story. We look at analyst coverage, 10.9%, and then we look at the Herfindahl index significantly. So ownership concentration of the firm, we see a significant increase there as well. We, on the flip side of that, we don't find any evidence for industry emissions profile, which was surprising to us. We hypothesize, obviously, there's a lot of firms in the S&P 900, and the sample isn't skewed perfectly. So we're going to do some further investigation into the possible cause behind that with a different sample as well. Looking at firm profitability and firm size, we found that firm size was a key determinant of implementation of a science-based target. However, firm profitability in the period prior was not. So looking at the determinants, we found 4 key determinants of firm implementation of a science-based target. Now moving on to the juicier part of the paper, which is the market reaction. So first, it's important to identify how we measured cost of equity. So we take the mean of the following two methods, which are very commonly used in cost of equity papers. So the first is the Easton method, which is based on the Olson and Giordano abnormal growth model. And then we take the Clausen-Thomas model, which is based on the residual income model. Both of these rely on analyst forecasts 5 years out. And then we back solve to get the cost of equity, and then we average those across the two there. So once we've measured cost of equity, that then obviously becomes our dependent variable. We then have the independent variable of interest, which is SBTI, which is the same as last time, which takes the value of 1 in years where firm has implemented a science-based target. So regression 7 there, as you can see on screen, that's run to identify if there's a correlation between firms who have set a target and cost of equity capital. The second regression there, 7i, looks at uses an interaction variable and looks at the interaction between firms who have set a target and their emissions group. The way the emissions groups are split up is that we rank the industries on average emissions for the year. And then we quartile that across the sample. And we go highest emitters, high emitters, low emitters, lowest emitters. So moving on to the results of the linear regression. So as you can see here, there's a strong correlation between this implementation of a science-based target and a lower cost of equity. So as you can see here, 0.08% lower cost of equity, 0.059 to 0.012 lower cost of equity for firms who have implemented a science-based target. And as you can see over there on the right, the visual representation, it's quite obvious that the treated firms in the sample have a lower cost of equity. So while this obviously does imply that there is a correlation, it doesn't essentially prove causation. There are multiple endogeneity concerns, and lots of things can impact cost of equity. So to increase the robustness and do further investigate the causality, we then run two things. So we run a difference in difference exogenous shock model, and we look at a PSM sample. So the difference in different model is obviously going to better isolate causality. The treatment variable in this case is obviously the implementation of a science-based target. The post variable was set as the election / inauguration of President Biden at the end of 20 and start of 21. So essentially 2021. So essentially taking the firms who have set a target in 2021. Now, the reason that we've done this is because obviously the post variable for a lot of these firms is at different times. So we want to look at when the Biden was elected, so we can have that one post variable.
Fraser, you have 2 minutes already.
Yep. Moving on to the cost of then this regression 8i is the same as before, and we look at the emissions group again. We then estimate a propensity match sample to increase the robustness of the results. So we use the regression on the right there to estimate the propensity scores, and then obviously rerun the following two equations on the left. So moving on to this section, the key finding here is that while there is a correlation between firms with an SBT and a lower cost of equity, this is not due to the implementation of the science-based target. And this does not change for firms in any emissions group. So as you can see there, the treatment variable, science-based target, is pretty similar to the last findings. The post variable is very similar, is a bit higher across a couple of the estimates. And then we see when we look at that interaction variable, the variable of interest, there's no significance and no direction. So essentially saying that firms the lower cost of equity is not due to the implementation of a science-based target. Looking at the propensity match sample, these results are robust to the propensity match scoring system as well. So the key findings, so obviously we found the 4 determinants of firms that implements firm implementation of science-based targets. It's high number of industry peers, effective internal and external governance mechanisms, and large, well-resourced firms. And then the market reaction side, we found that firms who have implemented SBT have a lower cost of equity, but that's not due to the implementation of a cost of equity. So combining the two findings, we hypothesized that large, high-quality firms are more likely to implement a science-based target. These firms have an inherently lower cost of equity regardless of the setting in SBT. Therefore, when they implement an SBT, they aren't actually allocated a lower cost of equity. And therefore, it's implied that markets do not identify the setting of an SBT as an effective way to reduce climate risk, and subsequently don't lower a firm's cost of equity. So we've run, in the sake of time, I'll skip this, but we've run a couple of robustness tests, and all the firms hold up, all the results hold up to these robustness tests as well. So just quickly looking forward, as I'm looking to seek as much feedback as possible, realizing this paper needs to be refined before moving to peer review, we plan on conducting the following changes. So one, changing the data from yearly to quarterly so we can get a more granular look at the effect of the exogenous shock models and the sort of more granular, the changes that are happening. And the second is realizing the results in the market reaction section were underwhelming. Evaluate how institutional owners react by looking at institutional holdings around the implementation of a science-based target as well. Other than that, thank you very much.
Thank you, Fraser. Fantastic presentation. Now your paper will be discussed by Ivan.
G'day, Fraser. We're just getting our slides set up. So really enjoyed reading this paper. It's really a cutting edge topic. Yeah, I think you're onto something. This sort of science-based targets is, something practitioners are talking a lot about. But as you show in the paper, there isn't an awful lot of academic literature. So to summarize, but I probably don't need to because you did a great job of it. So you really have to research questions. So what are the characteristics of those firms adopting science-based targets versus those that don't? And, getting to good papers are now looking at, well, what's the real world effect? So how does it affect cost of equity? Probably don't need to say why this matters, but, obviously firms are looking to transition due to climate, and this is the whole point of science-based targets, is that firms can transition. You had a sample of S&P 900 firms. I say large and small cap, I meant large and mid cap. You'd get data from science-based initiatives. So to answer research question 1, you use a time series logit model with firm and year clustering. And then for question 2, as you eloquently described, you had 2 cost of equity models, so a normal growth one and a residual income one. Use a baseline model and then due to endogeneity concerns, you use a D&D and propensity score matching, and you have a sort of conflicting hypothesis for what you call the meteor part of the paper, right? So greenwashing would lead to higher cost of equity, dealing with risk, lower cost of equity. So results part one, peer effect and size load are quite important. I guess these are not hugely surprising. R&D intensive firms, I noticed that the coefficient was really large in a couple of cases, so you may want to look at that. I don't know if you Windsorized or so on. And then you had the internal governance variables. So ESG committee had the dominating effect, board size and board gender diversity also loaded, but it was really that ESG committee that was most important. Actually, I think those internal governance ones are really important. And actually, I really like the first part of the paper. You described the second one as a meteor one, but I think I have some concerns about the second part of the paper. And I think, I wonder if you have two papers here, actually, but anyhow. And then there's the external governance ones. And again, I think there's potential to explore more stuff there. Results for part two, 80 to 115 basis points lower cost of equity. But once you do your D&D, the effect essentially disappears, right? So you're suggesting that lower cost of equity firms have science-based targets, right? And that's your conclusion. But, you know, when you were doing your introduction, you talked about firms adopting science-based targets that previously had targets. So maybe you're being too quick to reject your hypothesis. So you maybe need to control for the fact that firms had targets well before. And actually, that cost of equity is reflecting policies before, right? Mm-hmm. So, you know, so I think you might be throwing the baby out of the bathwater a bit too quickly. So, strengths of the paper. You know, I'm director of CEF Group. I could have chosen to review any paper. I chose this one because it's a really sexy topic. I really like it. And then I saw it was 90 pages. So interesting and policy relevant. You've done a lot of analysis. Honestly, for a master's student, you've done an amazing job. So, you know, congratulations. But it is 90 pages long. And so, you know, you have some great supervisors. You know, even people that have completed their PhD still struggle with writing, so the writing will need a bit of work. Yeah, and perhaps two papers. You might have two papers out of this, either one really chunky one or two. For the part one and maybe even part two, as I just intimated, focus more on those pre and post effects, right? So think about what's happened before and what's happened afterwards. And for part two, I just wondered, you know, you talk about market reaction and you've gone to cost of equity models. I confess I don't know too much about them, but, you know, a sort of robustness would have been to see what happens with just a standard old event study. But in part one analysis, you had the largest effect size, R&D, ESG committee. I worried that was greenwashing. So part one, why not try a match sample, right? So why don't you get rid of some of these kind of innate things of firms like control for size, ownership concentration, and so on, and then get at some of what I call the policy variables, right? So the ones that, you know, policymakers can influence, like board size and gender diversity. Yep. The other one in pre-effects is shareholder resolutions and climate litigation. Right, so maybe, and we've been doing work, and Caroline Flammer has been doing work on firms being pushed in this space. And a lot of firms have, I think a lot of these science-based targets will have come from shareholder litigation, or sorry, shareholder resolution saying, how do you align to 2 degrees, right? So again, I think this gets at these pre-effects, okay? And post-effects, you explained it much better. Here, there's a change in intensity. Yeah, and I would look at the, and I didn't really like how you said, oh, firms, this is a long-term effect. If you'd listened to Andreas Heppner this morning, he says these are not long-term effects. Firms need to be cutting 7% per year. Yep. You know, CO2 you can cut quite easily. You know, yeah. Sorry, I'll go quickly. And Daminda is ready to throw me out. Don't throw me out, Daminda. So event study. Yeah, so maybe using this, maybe splitting your sample between forced and voluntary. Genuinely, firms have done this voluntarily versus those that have been subject to litigation or resolutions that have been forced to do that. The D&D with Biden, you tried 2018, that was going to be a suggestion there. Okay,
Yep.
but I want to see visually, is there a structural break, right? I mean, you show in the chart for the 2000, for I think it's a sample of all firms that have science-based target, but why not show your US sample and see visually, is there a structural break to justify your D&D, right?
Yeah.
Yeah. Yeah, and I'll leave it at that. But great paper, really enjoyed.
Awesome. Thank you very much.
Thank you, Ivan. Fascinating discussion.
Yeah, thanks, Ivan.
Now, let us have about 2 minutes for question and answer session. Is there anyone from online for a question? You can unmute yourself. No. Then from the audience here.
I'll have a quick question, Fraser. Why do you use the 900 S&P firms when you can use all the firms in the US?
I think, yeah, the main reason is analyst forecast data is used for cost of equity. And then secondly,
but you should be able to get all the implied cost of capital from the whole US, I mean, the sample US firms, not necessarily 900 though.
Yeah, okay, yeah. And then I guess the other reason was, I think, you know, most of the emissions come from the top end of town. And these are the biggest emitting firms and the firms that are going to be really driving the change driving the decarbonisation efforts. Like one of the in the paper, it does go into that expanding the sample is definitely will be happening once you know, we expand the data. It was just, yeah, I had a year to write it, so, and had to be more concise. Yeah.